Hi everyone, this is TOC 5 for Unit 7. In these notes we are going to interpret scatter plots. So your question is, how do I interpret scatter plots? So let's talk about what a scatter plot is. It's a graph that's made up of points that are used to show a correlation between the topics. So you're probably wondering what a correlation is, and that's when it has a relationship between the x values and the y values. So the two topics that we're talking about. What are the four types of scatter plots? And it's important for you to be able to look at a scatter plot and recognize the relationship or the correlation. So let's first look at this first one, positive linear relationship. So for this one, as x increases, our y also increases. So this is creating a positive relationship. Whereas with our negative linear relationship, as x is increasing, y is decreasing. It's going down. If you were to start at the top of this hill, you'd be going down. So this is a negative linear relationship. If any of the points create like a curve or something that isn't linear, then we call it a non-linear relationship. So this is making a curve. And then when the points have no pattern at all and they're kind of scattered about, then we call that no relationship. Okay, so we're going to look at these 5 examples. We're going to look at these 2 graphs and identify what type of relationship is going on. So as we look at this first example, the television example, our x value is the television size and our y value is the price. So as we can see our points, if you were to buy a television that's 20 inches, you're going to pay, looks like it would be about $200. And then as your TV gets bigger, you're going to end up paying more. It's not perfect. It's not it doesn't have a perfect slope. That's what scatter plots are. They're not going to have a perfect slope, but as our television size increases, our price also increases. So since they're both increasing, this is a positive relationship. Okay, so let's look at our next graph. So this green graph is talking about a person's age, that's our x value, it's on the x-axis, and the number of pets they've owned. And as you can kind of see, there's like no pattern because someone that's 30 has had no pets, whereas someone who's 10 has had 3 pets, someone who's 40 has had 6 pets, someone who's 70 has only had 1 pet. And if you think about it logically, if you think about a person's age and how many pets they've owned, there's not always a relationship because some people just simply don't like pets. So because of that, since there is no pattern, then this is no relationship. All right. Number 4, shoe size of a student and a student's IQ. So again, think about these 2 things. Does someone's shoe size, will that affect their IQ, how smart they are? No. So this has no relationship. Whereas if we were talking about shoe size and height, or shoe size and length of arm, we may see some sort of relationship between those 2. Okay, let's look at number 5. So number 5 says, time since a train's departure. So if the train leaves the station, I'm counting the amount of minutes I'm sitting on the train, I'm counting the amount of minutes we've been gone from the station. So that time is going up. And it may help you in these situations to label them like this. And then as our time is going on since leaving the train station, our distance to our destination is going down, because as time is going on, I'm getting closer to my destination, so the distance is getting smaller. So if something is going up and something is going down, then this is a negative relationship. Okay, let's look at the last one. So the height of and I just want you to go ahead and cross off bouncing ball. I just want it to say ball. The height of a ball and the time since it was dropped. So this is telling us that you're holding out your hand, you're going to drop a ball. And so if you're dropping it, the height is going to decrease, but the time since you dropped it is going to increase, because you're going to be counting up in time. So since these are different, since one is going down and one is going up, this is a negative relationship. The reason why I crossed off bouncing is, if you think about it, if you were to drop a bouncy ball, it would go down and it would bounce back up. And that's something that you're going to see in the future in your algebra courses about what type of relationship that is. But we didn't want to confuse you, so we're just talking about dropping a ball. All right, guys, we are on the back now, and we're talking about line of best fit. That is a line you can draw in the same direction of the points plotted. When you are drawing a line of best fit, the reason why you're doing this is so that you can make approximations, you can make estimates based off of the data that is given, because this data is not continuous. This data does not have a continuous slope. This is information that we've been given from different so this one, for example, is going to be different sandwiches. So they're not perfectly lined up, but with creating a line of best fit, we're able to make those approximations. So let's look at this, this scatter plot right here on sandwiches. All right. So let's look at question number 1, which is over here to the right. It's telling us that our X value is the fat in grams for sandwiches, and then our Y value is the calories. So it's asking us how many calories are in the sandwich that contains 17 grams of fat. So we look for our sandwich that has 17 grams of fat, and it looks like 17 would be right about here. So when I go up, I notice that my calories are at 400. So we've got a point right there, so we can write exactly the amount. So 400 calories. I'm going to go ahead and erase what I drew on the graph. Okay, now this question is asking how many grams of fat are in a sandwich that contains 600 calories. And we can find a sandwich that has 600 calories. So we need to look at our Y values. If we look at 600, there's a point at 600, and when I go down, it has 30 grams of fat. Okay, and then let's look at question 3. What happens to the number of calories as the number of grams of fat increases? So as we can see, as our fat increases, our dots are also increasing. That means our calories are also increasing. So calories increase. Okay, so now we're going to get to the part where we're going to draw a line of best fit so that we can make approximations based off of the data that's given. So it says to draw a line of best fit on the given points of the graph above. If you have a ruler at home, that now would be a great time to grab one. If not, if you have something like a book or anything with a straight edge, now would be a great time to grab that. If you have a ruler that is clear so that you can see through the ruler, that would be awesome. Because when you are doing a line of best fit, you want to make sure that you have if possible, you want to try to have an even amount of points on each side. I'm going to try to make mine as straight as possible. But as you can see, I tried my best to make sure that I have points on the left side, on this side over here, and I have points on this side over here. So it kind of should go pretty much through the middle of the data. So I'm going to write a little note right here. Try to have an even amount of points on each side. Okay, and now this is asking what type of correlation or relationship, those are synonymous, can you see between fat and calories? So, as we said, this is a positive relationship because as fat increases, calories also increase. They're both increasing, so this is positive. All right, the last section of these notes. So we're looking at the amount of hours worked, which is our X value, and their earnings, the money that they received. So scatter plot shows the total earnings, wages, and tips of a food server during one day. About how many hours must the server work to earn $70? Okay, so what we're going to first do is let's first draw a line of best fit. So grab your ruler or grab a straight edge or something that is straight and draw to the best of your ability a line of best fit. See, I think I could do a little bit better at drawing that line. So I'm going to erase because I want to make sure I try to have an even amount. All right, that's about as good as I'm going to get. So it's asking about how many hours must the server work to earn $70. So 70 is a Y value. And if we walk on over to 70, and if we go on down to our X values, we would be at about 3.5. So in order to get $70, the person would need to work about 3.5, you can say 3.5 hours. And that's an approximation because we're using our line of best fit to help us. About how much did the server earn for 5 hours of work? So now we're going to look over at 5 hours, and this is an X on the X-axis. And when we go up, well, they did work 5 hours, and it looks like they're in between the Y value of 80 and the Y value of 90. So that would be $85. So that was a point that did fall on the graph. So we can write $85. And then this is asking us to describe the relationship. And it is a positive relationship or a positive correlation because as hours, and that's our X value, as hours increase, earnings increase. All right, awesome job, guys. We are going to go over this in class. Thanks for watching this video. Have a good rest of your day.